Good morning. Today we are discuss about the nanoscience and nanotechnology. Nanoscience and nanotechnology. What is nano? Nano means 1 billionth of meter. Nano is a Greek word which means draft or reduction in size. The scale of some small things. A red blood cell is roughly 10 millihumeter, equal to 10,000 nanometer. A DNA strand is roughly 2 meter wide. Tree ball and is a resolution naked eyes. Human hair, red blood, coronavirus is optical microscope. Carbon nanotube fluorescence is viewed for electron microscope. Nanoscience. It is a study of material having dimension in nanoscopic scale 1 to 100 nanometer. This is a nanoscale. Nanoscience focus on the study of physical, chemical and biological properties of nanoscale material. It gives theoretical concept only. Nanotechnology. It is the science that deals with the matter at a nanoscale. History of nanoscience. The first ever concept is given by famous professor of physics Dr. Richard B. Feynman. Invention of the scanning tunneling microscope in 1981 and the discovery of the fluorescence in 1985 led to emerge of nanotechnology. The term of nanotechnology was coined by Nario Dangli in 1974. Nanomaterials. Nanomaterials means graphene, fluorescence, nanotube, nanowires, nanocone, quantum dots, nanostructures. Is all our nanomaterials. This is for the structure of fluorescence, carbon nanotube, quantum dot and nanowires. Properties of nanomaterials. Nanomaterials have a properties that are different from those of bulk material. Most nanostructure materials are crystalline in the nature and they possess unique properties. Physical properties of nanoparticles. Crystal structure of nanoparticles is same as bulk structure with different lattice parameter. The inner atomic spacing decreasing with size and this is due to long range electrostatic force and the short range core repulsion. The melting point of nanoparticles decreases with size. Chemical properties. The electronic structure of nanoparticles is dependent on the size and the ability of nanocluster to react depend on the cluster size. Electrical properties. The electronic structure of nanomaterial is different from its bulk material. The ionization potential at nanoscience are higher than that for the bulk materials. Magnetic properties. The magnetic moment of nanoparticles is found to be very less when compared with them with its bulk size. Nanomaterials made of semiconducting materials. Semiconductor materials, germanium, silicon and etc. Classification of nanomaterials. Based on their origin. Non-internally made materials. They are occur naturally in the environment. Virus nanoparticle produced from diesel combination. Intensity made nanomaterials. These are produced delivered through a defined fabrication process such as engineered nanomaterials. Example, cosmetics, electronics. Based on chemical composition. Carbon-based nanomaterials mainly composed of carbon nanotubes, fluorescence, graphene. This is for example or carbon nano-based material. Metal-based nanomaterial composed of different metals. These nanomaterials include silver, copper, iron, gold. Metal oxide based nanomaterial. These nanomaterials are constituted of metal oxide include titanium oxide, zinc oxide, mainly used in UV blocking agent fuel cells. Dendrimers. These are nanomaterials or nano-sized polymers which are made from branched units. There are numerous chain end of the surface of the dendrimers. These end can be tailored to perform a specific chemical function. Example, drug delivery. Based on its dimension. 0 dimension. Example, fluorescence quantum. 1 dimension. Example, nanotubes. 2 dimension. Example, nanodisk. 3 dimension. Example, embedded cluster. Synthesis of nanomaterials. Bottom of methods. It involves the assembly of atom or molecules into nanostructure arrays. Raw material source can be in the form of gas, liquid, solid. It is classified into 2 types: chaotic and controlled. Top-down method. It adopts some force to break bulk material into nanoparticle. A popular method is ball milling. Figure. Ball milling is bottom of top down. This figure of bulk materials. Synthesis method. Chemical method, physical method. Chemical method means salt gel method, Mixella and inverse Mixella method, condensation method, salt method, hydrothermal method, solved thermal method. Physical method: thermal decomposition, plasma-origin, evaporation deposition, electron beam physical vapor deposition, sputter deposition, cathodic arc deposition, pulse laser deposition. Application in microelectronics. The reduction in size of electronic components leads to faster switching times in computers. Quantum computers use fast quantum algorithms and have quantum bit memory space, so it involves in several computations at the same time. In medical field, nanomaterials are used for the development of diagnostic devices, drug delivery system. Iron nanoparticles are used in cancer treatment. In textile industry, clothes are made of nanofiber which are water and strain resistant and wrinkles free. Energy. Solar planets that double the amount of sunlight converted into electricity. Nanotechnology also lower cost, produces stronger and lighter wind turbines, improve the fuel efficiency. Food. In this field, nanobiosensor would be used to detect the presence of the pathogens in the food or nanocomposites to improve food production. Nanotechnology used in everyday life. Nanoparticles silver are used to deliver antimicrobial properties in hand washes, bandage and shocks. Zinc or titanium nanoparticles are the active UV protective elements in modern sensors. That's all.